Alright, now let's start using these function equations to model real-world situations. So, suppose that starting at age 22, you begin to save for retirement. You already have $5,000 in savings from selling your car, and additionally, you have $3,600 taken from your paycheck every year and put into your retirement account. Now, creating these equations to describe these real-world situations is something we're going to do a little later. But what I want us to be able to do now is, if we're given an equation, using it to our advantage. So we have two equations below, and in the first one, we're going to have K equal our retirement savings. And the variable H is going to equal our age in years. Note that the slight difference in the second equation is that we have this variable W, which represents the number of years since you were 22. So one variable represents our age, one represents the number of years since we were 22. Alright, so in our first question, how much will we have saved after 20 years of saving when we are 42 years old? So first things first, I want to concentrate on when we are 42 years old. Well, in our first equation, we have a variable that represents our age. So if we want to know how much we have in savings when we're 42, all we need to do is substitute a 42 in for this variable, which represents our age. So our savings will be equal to 5,000 plus 3,600 times 42 minus 22. Just substituting 42 in for our age. And now I'm confident that you can go ahead and figure out how much you'd have in savings. So we find that when we're 42 years old, we should have $77,000 in retirement savings. Now what if we use the other equation, and we use that it had been 20 years since we began saving? Well, since this W represents the number of years since we began saving, since we were 22, let's go ahead and substitute a 20 in for this variable, which represents how long we've been saving. So we get K equals 5,000 plus 3,600 times 20. Now it should be no surprise with a quick glance to the left that of course we're going to end up with the exact same number. And that's reassuring. And it just goes to show that with two different equations with slightly differently defined variables, we can come up with the exact same answer. Okay, let's turn our focus to the second question. How many years will it take you to amass $127,400 in retirement savings, and how old will you be? So the first one I want to look at is, how old will you be? So when we see that, let's use our first equation, and all we're going to do is we're going to substitute $127,400 in for our retirement. So we have $127,400 equals that 5,000 we started with, plus 3,600 a year, times h minus 22. And now all we have to do is, if we can solve for that variable h, we'll know exactly how old we are when we reach 127,400 in savings. And after doing some steps with this equation, we end up with 34 equals h minus 22, and we find that we will be 56 years old when we reach that mark in savings. So, if we look at our second equation and we substitute that same number in for our savings right here, we end up with 127,400 equals 5,000 plus 3,600 times W. And this W represents how many years you've been saving, or how long it's been since you were 22 years old. And when you solve this equation, you find 34 equals W. And note that this doesn't mean that your age is 34. This means it's 34 years since you started saving at 22 years old. So of course, that means you'll be 56. We end up with the exact same answer. Alright, here's another one, and a completely made up, fictitious example. None of this actually happened. Suppose that on August 1st, 2013, it became public that Facebook was selling user information to telemarketing companies. This included emails, phone numbers, pictures, and other private information that Facebook was supposed to keep secure. As such, people quickly stopped investing in Facebook and the company's stock price declined. The stock price was $27.50 on August 1st, 2013, and it fell by $2.40 each month after that. So below, we have two different equations to describe the relationship between the stock price and the time. In both equations, the variable D represents the stock price in United States dollars. In the first equation, N represents the number of months since August 1st, 2013, and in the second equation, H represents the number of months since January 1st, 2014. So here we go. If the Facebook stock were to continue to fall at this rate, what would the stock price be on December 1st, 2013? So let's use our first equation. Well, in this case, N represents the number of months since August 1st, 2013. So we got to figure out, on December 1st, 2013, how many months has it been since August 1st, 2013? So let's see. September 1st is 1 month, October 1st is 2 months, November 1st is 3 months, December 1st is 4 months after August 1st. So what we're going to do is we're going to substitute a 4 in for this variable right there. And we say that the stock price should be the $27.50 that it started at minus $2.40 a month times 4 months. And now all we have to do is evaluate. So we anticipate that on December 1st, 2013, the stock price should have been $17.90. What about using the second equation? So now our variable H represents the number of months since January 1st, 2014. So now we got to figure out December 1st, 2013, how many months since January 1st, 2014 is that? Well, what's kind of weird here is December 1st, 2013 is 1 month before January 1st, 2014. So we might say it's negative 1 month after. Since it's 1 month before, we'd say it's negative 1 month after. So what we're going to do is we're going to substitute a negative 1 in for this variable right here, which represents the number of months since January 1st. So we find that the stock price is going to be that $27.50 again, minus $2.40 a month, times, now we got negative 1 plus 5. And all we have to do now is evaluate, and it should be no surprise after our very first step of evaluation that we end up with a line that looks exactly the same as the one we had before. So it's no surprise that we're going to end up with the exact same anticipated price of $17.90 on December 1st, 2013. Now, suppose that the Facebook stock price had already been falling at that rate for a long time, even before the selling of any user information. With that assumption, the question now is, on what day would the stock price have been exactly $32.30? So for both the first equation and the second equation, all we're going to have to do is we're going to have to substitute that value, $32.30, in for the variable D, which represents the stock price. So in our first equation, we're going to have the equation to solve $32.30 equals $27.50 minus 2.4 times N. And of course, N represents the number of months since August 1st, 2013. And in our second equation, we're going to have 3230 equals 2750 minus 2.4 times H plus 5, where H represents the number of months since January 1st, 2014. So why don't you go ahead and solve the blue equation for N and the red equation for H, and then determine on what day the stock price would have been $32.30. So when we solve these two, we find that N equals negative 2 and H equals negative 7, but right now that doesn't have any kind of real world meaning. What does that mean? Well, it means that according to our model, we suspect that 2 months before August 1st, 2013, the stock price should be exactly $32.30. So what's 2 months before August 1st, 2013? That's June 1st, 2013. According to the equation in red, we find that the stock price should be $32.30 7 months before January 1st, 2014. Well, what's 7 months before January 1st, 2014? June 1st, 2013. So again, two slightly different equations with slightly different variable definitions that yield the exact same result. All right, last example. Suppose that at 50 years old, in the year 1970, your grandfather sold his business for $140,000. He then invested it at an annual interest rate of 3.8% every year, hoping that it would grow big enough to send you to college when you're at college age. So we've got two equations to describe the relationship between the value of that investment and the year. In the first equation, we actually have the variable P representing the year. The variable K represents the value of the investment. In equation 2, we still have K. It also represents the value of the investment. But then we also have a variable A, which doesn't represent the year. It represents your grandfather's age. So, first question, if the investment continues to grow at this rate, how much would the investment be worth in the year 2000, which is when your grandfather would be 80 years old? So note that if you look at the year 2000, it's best to use the equation that uses the year as its variable. So equation number 1. And all we're going to do is substitute 2000 in right there for P. So we find that the value of the investment will be K equals 140 times 1.038 times 2000 minus 1970. One thing I should have pointed out is that the variable K represents the value of the investment in both cases in thousands of dollars. So in thousands of dollars here and in thousands of dollars there. Awesome. So now all you have to do is use a calculator to evaluate this and find out the value of K, find out the value of the investment. And when you do that, you find that the value of the investment will be approximately $428,596.52. If we use equation 2, all we need to do is substitute 80 in for your grandfather's age. So all we're going to do is substitute an 80 in there and evaluate once again. So we get K equals 140 times 1.038 times 80 minus 50, and we evaluate. Note to self, 80 minus 50 is 30. It's going to be the exact same thing as 2000 minus 1970. Of course, we're going to end up with the exact same approximate value of that investment at $428,000, $596.52. All right, and with the second example, all we're asking is for how much the investment would be worth in another year. Say the year 2050, when your grandfather would have been 130 years old. So in our first equation, all we're going to do is we're going to substitute 2050 in for the year right there. All right, so we end up with the value of the investment will be 140 times 1.038 raised to the power of 2050 minus 1970. For our second equation, all we're going to do is say, oh, if he would have been 130 years old, we're going to substitute 130 in for that variable A right there. And we have K equals 140 times 1.038 raised to the power of 130 minus 50. And once again, all you need to do is use your calculator to evaluate. And using each equation, you find that the value of the investment in the year 2050 will be approximately $2,766,408.54. Hey guys, that's it for this video. I hope you found it helpful and I hope you enjoyed.